Look up at the night sky and you might think you are seeing infinite freedom, but physics dictates you are actually staring at the walls of an inescapable cosmic prison. Thanks to the expansion of the universe and the stubborn forward march of time, 99% of reality is forever locked away from us. But today, we are not just looking at the bars of the cage, we are looking at the blueprints to break out. We are going to explore the ultimate boundaries of human reality and how we might actually escape them. To understand our cosmic prison, we first have to understand the warden. That warden is Albert Einstein. Under Einstein's theory of general relativity, gravity curves space and time. His special theory of relativity set the ultimate cosmic speed limit. Particles of light travel through a vacuum at roughly 300,000 kilometers per second. This is a speed that is immensely difficult to achieve and absolutely impossible to surpass. Because of this unyielding speed limit, humanity is trapped in a tiny invisible cage known as the human radio bubble. This bubble extends about 100 light years from Earth in every direction. It represents the absolute farthest extent of human influence in the cosmos, the outermost reach of our earliest radio and television broadcasts. Beyond this microscopic bubble, it is as if humanity never existed. Our entire recorded history is just a whisper in the cosmic wind, completely undetectable beyond this small sphere. Let us scale up and look at the physical distances trapping us. Earth is a tiny blue dot floating in an immense cosmic ocean. If you wanted to leave and just visit the moon, driving a car at 100 kilometers per hour would take you over 160 days. Traveling to Mars at the speed of a commercial jet would take upwards of 50 years, and that's just our local neighborhood. If we aim for Alpha Centauri, the closest star system to our sun at over 4 light years away, the reality of our confinement sets in. Using our current space travel technology, a journey to Alpha Centauri would take over 70,000 years. But distance isn't even the most terrifying part. The universe has been expanding since the Big Bang, stretching space itself. Some regions of space are expanding away from us faster than the speed of light, placing them forever out of our view. Distant galaxies are retreating endlessly into the depths of the universe. This means the true universe might be infinite, but our observable universe is shrinking relative to our reach. We are stranded. If space is locked, what about time? In some ways, we are traveling in time right now, but we happen to be prisoners of the present in the eternal transition from the past to the future. Einstein's relativity tells us that time slows down the faster you move. If you travel a good fraction of the speed of light, time will tick more slowly for you than for everyone back on Earth. You could leave for 10 years and everyone on Earth ages 100 years. You have effectively traveled into the future. Going forward is easy. Going backward is where the universe fights back. Traveling back in time introduces universe-breaking paradoxes, like the grandfather paradox. If you travel to the past, can you change history, or are you bound by fate? Consider the phenomenon of Kokura luck. During World War II, the primary target for the second atomic bomb was the city of Kokura. But a 50-minute delay, clouds, and intentional smoke obscured the city, sparing hundreds of thousands of lives by pure chance. If you traveled back in time to alter that day, the universe might fight back to protect itself. Russian physicist Igor Novikov developed the self-consistency principle. It states that anything a time traveler does in the past must have been part of history all along. You could never prevent an event from happening. Whether it's the fate of Kokura or your own existence, backward time travel removes human free will from the equation. So, classical physics traps us in space and locks us in a rigid timeline. But what happens when classical physics breaks? Even with Einstein, his equations cannot take us to the center of a black hole, or the very beginning of the universe. In those extreme places, his theories fail. They literally blow up on the page. When the physics of the massive fails, the physics of the tiny takes over. Quantum mechanics. In the 1920s, we learned that at a small enough scale, you lose the ability to predict behavior with precision. And when you apply quantum mechanics to the fabric of spacetime, you get a gurgling, shifting foundation known as quantum foam. This quantum loophole gives us our first real escape plan, the Alcubierre Drive. Proposed by theoretical physicist Miguel Alcubierre, this solution doesn't try to break the speed of light. Instead, it uses a configurable energy density field to contract the space in front of a spacecraft and expand the space behind it. You don't accelerate through normal space. You shift the actual fabric of space around you, allowing you to arrive at your destination faster than light would, without ever breaking physical laws. It requires exotic matter with a negative energy density, but mathematically, it's the key to outrunning our shrinking cosmic horizon. But what if we can never build the Alcubierre Drive? What if humanity is physically destined to remain inside this cosmic prison forever? There is one final escape route, and it doesn't require a spaceship. It requires understanding the multiverse. The multiverse isn't just an invention out of the ether. It flows directly out of the application of quantum mechanics to general relativity. There could be pockets of the universe that are expanding with no knowledge of any other pockets. Imagine two ships at sea, each with its own horizon, completely unable to see each other. Prominent scientists like Max Tegmark have devised classification schemes for these multiverses, mapping out exactly how reality is structured. The ultimate escape is what Tegmark calls the level 4 mathematical universe. This hypothesis considers all universes to be equally real, described by different mathematical structures. It suggests that abstract mathematics is not just a language we invented to describe the universe. Mathematics is the literal structure of reality itself. We might be confined by the speed of light, trapped in our tiny radio bubble, and bound by the relentless flow of time, but our minds are not. By mastering the equations of quantum gravity and mapping the structures of a level 4 multiverse, we connect to every possible reality. We escape our physical prison by proving that the walls themselves are just math, waiting to be solved.